All right, so we're going into lesson 2.3 and 2.4. And I am attaching these two together, guys, because they all talk about practically the same thing. We're looking at slope and writing and, I forgot graphing. Writing and graphing equations of lines. So essentially, we're looking at linear equations, guys. Now, some of this stuff, you should be very familiar with it. Like slope, is the, you know what, let me go ahead and just start a new screen because I have people complaining that there's too much on the screen. So I'm just gonna go ahead and start a new screen, okay? So guys, slope, when we talk about slope, remember we use the letter M for slope. By the way, the reason we use M is because it's from the verb to climb in French, monter, okay? So here, guys, this is the change in the vertical, and I'm trying to write vertical here. That's the Y over the change in the horizontal, change in horizontal. Now, I'm going to abbreviate this one. Change in the vertical over the change in the horizontal. We use delta to represent change, guys. We use the delta symbol, the character, to represent change. So if we're talking about change in the vertical over change in the horizontal, we could also represent it like this, delta Y over delta X. For those of you moving on to calculus, guys, eventually you will see the delta Y, delta X used in your calculus courses, all right? Now, when we talk about a change, obviously we have to compare two things. So the change in the vertical is represented as Y2 minus Y1, while the change in the horizontal between the two X values is represented as X2 minus X1. Now, guys, just remember, okay, it doesn't matter whether you do Y2 minus Y1, X2 minus X1, or perhaps you go ahead and do Y1 minus Y2 over X1 minus X2. It's still the same thing. As long as you are consistent, you will arrive at the same answer. It's still the same formula, guys, all right? So when we talk about slope, some of you commonly refer to slope as the rise. Once again, rise having to do with the Y values over the run having to do with the X values, guys. So for the slope itself, people, there are 4 different types, okay, of slopes we look at. Now, when we talk about the slope in and of itself, it measures the steepness of a line. How steep is the line? Sometimes slope is referred to as the gradient, like the grade of a road. Sometimes it's also referred to as the pitch. And when we talk about the pitch, which we're looking at the pitch of a roof. Average rate of change is another one. The average rate of change, guys. Average rate of change. And as you guys go further into the mathematics curriculum, one of the things that you guys are going to see later on is this, especially in calculus, the derivative, dy over dx, guys. This is actually slope, the derivative, the first derivative. That's what this is, okay? So you will see this when you get to calculus. Enough of that. So what in the heck am I talking about? Now, if I'm talking about, let's say, a segment or line AB, this is A, and here's B. Now, A is located at 2, 3, while B is located at 5, 7, guys. Now, if I want to know the steepness of this line AB right here, I have to figure out its vertical change over its horizontal change, guys. It's vertical change over its horizontal change. Now, I don't mind using all the variables. I just think it makes more sense to go ahead and use concrete examples. It makes more sense when we use the concrete examples. Now, guys, listen, I want you to use some common sense here because I don't want my students relying on formulas. Use some common sense. It makes a lot of sense to just go ahead and use that common sense. Okay, guys? So for the horizontal change, we are traveling from +2, x is at +2, and we move over to +5. So to travel from +2 to +5, there's a change in the horizontal of 3 units. There's a change of 3 units. We've traveled 3 units in the horizontal direction. Now in the vertical direction, we're starting down here because this is at 2, 3. We're starting down here at 3 and we're traveling vertically to 7. So in order to travel from 3 up to 7, guys, the change in that vertical from 3 to 7 would be 4 units. And so just like that, remember the slope is the rise, which is 4 units, over the run, which is 3 units, you have your slope. Or you could say the change in the vertical, which is 4, over the change in the horizontal, which is 3. Now notice, guys, I did not use the formula. I just used good old-fashioned common sense. So you do not have to rely on that formula, okay? Now, for those of you who love to use your formulas, when I do this with my students, I like labeling points. So I'm just gonna label the first point as x1, y1, the second point as x2, y2, and then to calculate the slope, obviously we're going to do y2 minus y1 over x2 minus x1. So plug in the values, substitute the values, and 7 minus 3 over 5 minus 2. So the difference between 7 and 3 is 4. The difference between 5 and 2 is 3. Guys, we're arriving at the same value, okay? So for every unit, every 4 unit we go up, we travel 3 units in the horizontal direction. So for every 4 vertical unit, we travel 3 units in the horizontal direction. That's slope, guys. Now, as I mentioned before, there are 4 cases for the slope. We have a positive slope, which rises from left to right. You could also say this, it increases left to right. And the reason why I'm using this term, guys, is to get us ready for chapter 3. So if it's got a positive slope, it will increase from left to right, or you could say it rises right. And if the slope is negative, the opposite. Notice, guys, when we graph, we go from left to right. We could say it decreases to the right, or like you guys are familiar with, it falls to the right. It falls right. And you do need these descriptions because some of the questions in my math lab will ask you for the descriptions, okay? So if a line has a positive slope, it increases to the right from left to right. However, if it's got a negative slope, it decreases from left to right, because when you're graphing, guys, you always go from left to right. Now, there's 2 more cases. I'm erasing this so I could show you the third case. The third case is 0, guys. When we talk about 0 slope, let's consider what this means. If, okay, you have a slope of 0, this means that the numerator is 0 and the denominator can be any value. So what is happening? There's no rise. So this problem is simply running. So if it's simply running, what you end up with is a horizontal line. And so when you have a horizontal line, guys, think about which axis it intersects. It intersects the y-axis. So therefore, when you write the equation, which is where we're heading to, when you write the equation of a horizontal line, because it is intersecting the y-axis, it's going to be in the form of y equals to some value. So once again, guys, if the line is horizontal, that means that the slope is equal to 0, because 0 divided by any number is 0. However, okay, when you graph this, the graph is going to intersect the y-axis. So therefore, your equation must be in the form of y equals to b. Now, here's something that might help you if you're not sure whether 0 divided by some number is 0 or if it's undefined. If the 0 is in the numerator and you call the denominator k, it's okay for this to equal to 0. It's okay for it to equal to 0. All right, guys. Now, here's the last scenario, and that is when the slope, guys, ends up with a value in the numerator and 0 in the denominator. When the slope has a value in the numerator, it has a rise. Oops, I meant to put a rise. Let me erase this, okay? It has a rise, but no run, guys. There's a rise, but no run. So if that's the case, then what does the graph look like? It looks like a straight up and down vertical line. So when you have these vertical lines, guys, okay, the question you have to ask yourself is this. Is this a possible scenario where a line could go straight up and down? Okay, that's the question. And so on this one right here, when the 0 is in the denominator, we refer to the slope as undefined. It's undefined because you cannot divide by a 0, and it is impossible, guys, to go up a line that is straight vertical. There's no such thing as a straight vertical line. That is completely impossible. Now, additionally, because this is a vertical line, it intersects which axis? The x-axis. So because it's intersecting the x-axis, when you write the equation of a vertical line, it is going to be in the form of x equals to some value wherever it intersects the x-axis at. Now, additionally, if you cannot recall which one is 0, which one is undefined, if your 0 is in the denominator and you have an arbitrary value in the numerator, and notice I'm putting the letter N, this one is saying no, 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 okay? It cannot equal to 0. Can't be 0. So if the 0 is in the denominator, it is not 0, but rather it is undefined, guys. So these are the 4 cases for the slope. Now, once we're done with this part, guys, the next part of this has to do with the writing of these equations of lines. When it comes to writing equations of lines, and I will be doing examples with you guys later on. We'll go into the assignment and work some of these problems out together. Writing equations of lines. When we are writing equations of lines, guys, pretty much you need 2 components to write the equation of a line. The majority of the time you will need 2 components. You need a slope, that's M, and you need a point. And that point will be represented as x1. Oops, fix that there. Okay, x1, y1. So once again, when you're writing the equation of a line, guys, you typically need 2 components. There are, of course, exceptions to these rules. Okay, you need a slope and you need a point. If you have a slope, you have a point, you're going to substitute the point and the slope. Okay, now look at how nice this fits in there, guys. Into the point slope formula. Now you are going to need the point slope formula, guys. And the point slope formula is simply this. Y minus y1 is equal to m times x minus x1. Now, additionally, guys, you can also rewrite this by moving the y1 over to get y equals to m times x minus x1 and then plus y1. So these 3 equations are exactly the same thing. Now, let me just say this. On my math lab, you are required, guys, when they ask you to write the equation in point slope form, you must make sure that it's in this form. I know sometimes some of these problems, they go against the grain, but listen, adhere to it because they want to see the form, okay? So that's the point slope form, guys. Additionally, every once in a while, they may ask for the SlopeIntercept form. If they ask for the SlopeIntercept form, they will just want you to, ooh. Okay. I think, all right. I think my speaker was coming on. Okay, so if they ask you for the slope-intercept form, guys, it's just like what it sounds. You have a slope and then you have an intercept. What intercept are we talking about? We're looking at the y-intercept. So the slope-intercept form, guys, is y equals mx plus b. Now, given a point and a slope, you can go straight to the slope-intercept form, and that's fine. However, when the problem says, I want point slope form, and then I want slope-intercept form, yeah, you got to produce both of them, guys. So it's not about whether or not you want to use slope-intercept form or you want to use point slope form. It's more about what does the problem require. If the problem says point slope first, slope-intercept second, you got to do it that way, guys. Okay, so right here, guys, your y-intercept is your b value. Remember, when you substitute 0 in for x, you end up with b. So if x is 0, you're left with y equals to b. That's your y-intercept right there. And everybody, of course, knows that m is your slope. So pretty much once you have your point slope, just solve for y. Solve for y. Now, guys, the other thing is this. Sometimes they will ask for the equations in function notation. We talked about this in the last video, which you guys need to watch. Function notation is f of x. So f of x would replace the y. So another way to express these equations, f of x equals to mx plus b. This is the same equation. What is the difference? F of x is replacing b, or y becomes f of x, or f of x becomes y. So if you want to, on the side, guys, you might want to write this down. F of x is y, and y is f of x. So until you feel comfortable with function notation, just keep using y. It really doesn't matter, okay? Just be careful, though, when you are in my math lab, some of the problems require function notation. All right, and then last but not least, in terms of the type of equations, the different types you might have to express this equation is in standard form, guys. Now, if they ask you to write an equation in standard form, and they rarely ask you to write them in standard form, we're looking at ax plus by equals to c. Now, when you write standard form, you're not allowed to have fractions. No fractions, guys, in standard form. No fractions in standard form. All right. So I am going to, let me see here. Maybe I should do a couple of examples. Yeah. Okay, let's go ahead and do a couple of examples. And then I will move on. All right, guys. So here's the first example. You are given a slope of 2/3, and the line, the graph of this equation is going to passing through the coordinate point 6, -2. So for this one right here, guys, they give you a slope. This is your m value. They give you a point. This represents x1, y1. They want you to write the equation in point slope form and then slope intercept form. So you want to go to the point slope formula, okay? And you are going to substitute these values in. So you are going to substitute 6 for x1, okay? That's your x1 right there. And then you're going to substitute -2 for the y1. And then you're going to substitute 2/3 for m. So once you do your substitution, guys, this is what you're going to end up with. Y minus a -2 is equal to 2/3 times x minus 6. And then, of course, you want to clean it up a little bit. So you get y plus 2 is equal to 2/3 times x minus 6. So this would represent the point slope form. And yes, guys, this is how the computer wants it. This is how my math lab wants it. So you have to make sure you show the point slope form. When they ask for point slope, you have to provide the answer this way. All right, so now we're going to go ahead and transform this to slope intercept form. So guys, here we go. Y plus 2 is equal to 2/3 times x minus 6. We're going to rewrite this in slope intercept form. So we're going to distribute the 2/3, okay, essentially we are just solving for y. So we get y plus 2 is equal to 2/3 x minus, remember, you're multiplying here, guys. Let me go on the side here so I can show this to you. You're multiplying 2/3 times -6. Okay, I should use a different color here. 2/3 times -6. 3 goes into -6. How many times? -2. -2 times 2 is a -4, guys. Now, listen, the other thing you could have done is 2 times -6 divided by 3. Same thing. 2 times -6 is -12. -12 divided by 3 gives you a -4. Same thing, guys. It really doesn't matter. Now, the last step to solve for y is to go ahead and subtract the 2 from both sides. So this cancels out, leaving you with y equals to 2/3 x minus 6. And there's your equation in slope-intercept form. So if they ask for slope-intercept form, make sure it's in the form of y equals 2. Now, additionally, I need to say this. If they wanted to have function notation as a function, guys, you are simply replacing y with f of x. So as a function, this would be f of x equals to 2/3 x minus 6. And that's it. Okay, guys, I like questions, so make sure you're asking questions, especially if you're lost. Ask me a question. Anybody? All right, so we're gonna keep going, guys. Now, let me do one last thing with this problem, and that is to write it in standard form. So we're gonna take this problem and rewrite it in standard form. So here's where we are so far with the problem. Y is equal to 2/3 x minus 6. Now remember, standard form is ax plus by equals to c. So if we want to write this in standard form, we have to have x and y on the left side. And of course, no fractions. It's up to you what you choose to do first, guys. But of course, when we're working with these equations that contain fractions, the first step is to eliminate the fractions. So I'm going to multiply everything by 2. So when I multiply everything by 2, I end up with 2y. 2 times y is 2y. 2 times 2/3. Ooh, Shazam. I should be multiplying by 3, guys. That's sad. That's not good. Okay, let me fix that, guys. I'm fixing it. Okay, so I'm multiplying everything by 3, the denominator. So this should come out to 3y. The 3's will cancel out, leaving us with 2x. 3 times 6 is 18. Now, we're not quite there yet because this is what standard form is supposed to look like. So the last step to this, guys, is to take the 2x, move it over to the other side. So you're left with a -2x plus 3y is equal to -18. Now, this is sufficient, guys, for standard form. But every once in a while, especially on a multiple choice test, be on the lookout, guys. Because you see, the x is negative. We have a -2x. If we don't want the leading coefficient to be a negative, we might want to change it to a positive by multiplying every term by -1. Or just changing all the signs. If we were to do that, we'd end up with 2x minus 3y is equal to 18. So what I'm telling you is this. Be careful, guys. Yes, this is fine. But you could also see this one down here. They are both the exact same equation. And that's standard form, guys. Any questions? All right. So I am going to go ahead and move on to another example. Now, this second example here, they are giving you 2 points. Remember, when you are writing the equation of a line, guys, you need 2 key components. And those key components are the slope and a point. Now, we have points, but we are missing the slope. So given 2 points, you have to find the slope first. Find the slope first, guys. Find the slope. So to find the slope, we are going to go ahead and calculate the change in the x's over the change in the y. Now, guys, for those of you comfortable with your formula, go ahead and use the formula. But do we have to use the formula? No, we don't have to use the formula. Because I'm displaying this, I am going to use the formula. But if I was in the classroom with you, I would actually do it without using the formula. You know what? Let me do both. How about that? Think about it this way, guys. We are at -3, 6, and we're going to 3 comma negative 2. So let's look at the change in the y's, the change in the vertical. You're traveling from positive 6 to negative 2. So you're traveling backwards from positive 6 to negative 2. So you would travel negative 8 units backwards, okay? You would travel 8 units to the left. So because you're going to the left, that would be a negative. Now, on the other hand, for the change in the horizontal, you're going from negative 3 on the left side of the number line to positive 3 on the right side of the number line. So you're going to travel 6 units in the positive direction. So this would be your answer, but you got to simplify it, guys. And when you simplify it, what do you get? Negative 4 over 3. So guys, there's your slope. Now, for those of you who do want the formula, here it is. This is your first point, so that's x1, y1. This is your second point, so that's x2, y2. So if we go into the formula, y2 minus y1 over x2 minus x1, this will become 6 minus negative 2 over 3 minus negative 3. So 6 minus negative 2 becomes positive 8. 3 minus negative 3 becomes a positive 6. And then you want to go ahead and simplify this, guys. You know what? I made a mistake here. Y2. I did the wrong thing, guys. Shazam. Okay. Right here. Okay. And you guys are not even telling me. So that means that you guys are not even paying attention. Oh my goodness. Okay. 2 minus 6 is a negative 8, guys. Now, we want to go ahead and simplify this, reduce it. So negative 8 over 6 does reduce to negative 4/3. So there's your slope, guys. And once you have your slope, you can go ahead and use one of the points to write the equation of the line. So we have our slope. The slope is negative 4 over 3. And so we're going to use one of the points along with the slope to write the equation of the line. Now, does it matter which point you use? No, it really doesn't matter. You choose, guys. Now, personally, I like to go with either the one that has all positive values or the one that has the smaller numbers. I would go with point number 2, but I am going to use the first point, guys. So I am going to use the x1, y1. You can use the second point. It doesn't matter. So let's go into the point slope form, and then we're going to do our substitution. So here comes our substitution, guys. Now, y1 is 6, m is negative 4/3, and then x1 is negative 3. Now, you want to clean this up a little bit, and then this will reflect your point slope form. Negative negative 3 becomes positive 3. So, guys, there's your point slope form right here. That's the point slope form. Now, remember, you're not done with this because they will ask you to write the SlopeIntercept form. So guys, here comes the SlopeIntercept form. Okay, I am going to erase this so I can write the SlopeIntercept form. Okay, the equation was y minus 6 equals to negative 4/3 times x plus 3. So we're going to distribute the negative 4/3. So we get y minus 6 equals to negative 4/3 x. And then, of course, the 4/3, the negative 4/3 times 3. You can put the 3 over 1 if you want to. They cancel each other out. So you're left with a negative 4, guys, negative 4. And then last step, add 6 to both sides. And just like that, you have your answer. Y is equal to negative 4/3 x plus 2. And this is your SlopeIntercept form, guys. So I promised to do 2 examples with this. This is the second example. So I am going to stop here and move on to the next part, guys. Any questions on this one right here? All righty. So guys, here's another part of this. Sometimes they will be asking you to find the slope and the y-intercept given an equation. So given an equation, find the slope and the y-intercept. So when you get a problem like this, guys, and they ask you to find the slope in the y-intercept, be careful, okay? So what you need to do here is to go ahead and solve for y, as in isolate the y. Solve for y or isolate y. So here's an example problem, guys. It's 4x minus 5y minus 20 is equal to 0. Now for this one right here, obviously y is not solved for, so you have to go ahead and solve for y. So the first thing I'm going to do is take that negative 20, move it over to the right side. When I move it over to the right side, it will become a positive. Actually, you know what, guys? Let me also move the positive 4x as well. Let me move the 4x also, okay? It's a positive 4x over here. When I move it over to the other side, it's going to become a negative 4x. So I did 2 steps right there. I killed 2 birds with 1 stone. So essentially, this is no longer there. Remember, my goal, guys, is to solve for y. Isolate the y, get the y by itself on one side. So now the next step to get the y isolated, since negative 5 is multiplying y, I am going to go ahead and do the inverse of multiplication and divide both sides by negative 5. So this will simplify out to, hold on a second, let me take out this line. I'm going to do it by each term, okay? Divide each term by the negative 5. So this will simplify to y equals to positive 4 over 5x, and then minus 4, guys. So now we have the equation in slope-intercept form, so we can go about finding the slope and the y-intercept. Now, the slope, of course, is the coefficient of x, so m is 4/5. Then they may want the y-intercept. The y-intercept, guys, remember, be careful with this. The y-intercept, guys, is the b value once the equation is in slope-intercept form. In other words, if you substitute 0 in for x, what's the corresponding y value? Negative 4. So if you plug in 0 in for x, basically what ends up happening is that, guys, all of this cancels out. Oops, I erased the negative as well, okay? So that's all you're left with once you substitute that 0 in for x. So you got your y-intercept, you got your slope, and you're done. So guys, there you go. Any questions? No? All right. Guys, I know some of you don't want to ask the questions now, so just go ahead and hang on to your questions. The next part of this has to do with graphing of the lines, guys. So next, we're going to be graphing linear equations. And when it comes to graphing linear equations, guys, there are various techniques we use to graph linear equations. Of course, the old proverbial T-chart or T-table, it works really well, guys. Worst case scenario, if you should be lost when it comes to graphing, you can always fall back on the T-chart or the T-table. You know, where you choose a few values for x, like -1, 0, +1. You substitute them into the equation, find the corresponding y values, and then use those points, plot them in the xy plane, and sketch your graph. Like if you had y equals to 2x plus 3, okay? You could go ahead and plug in these 3x values and find the corresponding y values. So if x is -1, 2 times -1 plus 3 will produce a +1. So there's 1 point. And remember, guys, 2 points, when you're graphing on MyMathLab, 2 points determine a line. So therefore, when you're graphing in MyMathLab, guys, you must have 2 points. If you do not produce 2 points, the computer will not allow you to graph. So 2 points determine a line. You must have the 2 points. Remind me, and I will demo some of these problems with you. Now, if you were to plug in 0, 2 times 0 plus 3, this cancels out, leaving you with 3. If you plug in 1, 2 times 1 plus 3, although we really don't need this one, gives you 5. So you got 3 solid points, and you could go ahead, plot those in the XY plane, and sketch out the graph, guys. So that's the T-chart. Very reliable. Worst case scenario, you don't know how to graph an equation, go to the T-chart. Go to the T-table, guys. Select some values for x, substitute for y, and then find some coordinate points on the graph of the equation. So guys, here comes two of the most efficient techniques, and that is the X and Y intercepts to graph, the X and Y intercepts. That's one way. We're going to talk about them a little bit more. Or you could use slope intercept, which we just finished talking about. Remember, in order to graph an equation, you need 2 points. 2 points determine a line. The slope intercept form, guys, works really well, okay? So since you guys are very familiar with slope intercept form, I am going to start with the X and Y intercept. Now, for the X and Y intercept, guys, very easy. So here we go. The x-intercept is where a graph intersects, touches, crosses the x-axis. And of course, as a coordinate point, it's going to be some value for x and then 0 for y. So to find your x-intercept, you want to let y equal to 0 and solve. Let y equal to 0 and solve for x. And so likewise, if we're looking for the y-intercept, where a graph intersects the the y-axis, where a graph intersects the y-axis. Okay, I'm putting too much information here. I'm about to erase it, guys. Y-intercept is where a graph intersects the x-axis, the y-axis. I forgot to put the y-axis here. And so, guys, as a coordinate point, this one is going to be 0, b. And so when you're finding it, to find it, you want to go ahead and let x equals to 0 and then solve for y. I think I'm going to go to the next page and rewrite this, guys, the bottom part, because that was too much there, right there. Okay, that's too much information on this page. So x-intercept, 1 point. Y-intercept, 2 points. And once you have 2 points, guys, you're ready to graph. So x-intercept, when you're finding it, plug in 0 for y, solve for x. Y-intercept, when you're finding it, plug in 0 for your x value and then solve for y. And once you have those 2 points, plot them in the xy plane and go ahead and sketch your graph. All right, guys, so here we go. On this one right here, here's a quick example. Negative 4x plus 2y is equal to 4, guys. So there's a beautiful linear equation, and you have to graph it by finding the x and the y-intercept. By the way, I forgot to mention this to you guys, because now we're talking about graphing. So if you're in My Math Lab, and My Math Lab says you need to find the x and y-intercepts to graph, you must use the x and y-intercept to graph, guys. If you don't use the x and y-intercept, the computer will mark it wrong. Likewise, if it says use slope-intercept, you must use slope-intercept. When it comes to My Math Lab and graphing, it's very, very finicky. So guys, be careful with this. So let's go ahead and find the x-intercept. So when we're finding the x-intercept, we're going to substitute 0 in for y. So essentially, when we substitute that 0 in for y, this equation, guys, will become just negative 4x equals to 4. And then you solve for x, so x will become negative 1. And that's it. Now, as a coordinate point, this would be negative 1, the x value, comma 0. So there's 1 point. And remember, you just need 2 points to graph a line, guys. So guys, let's find the y-intercept. To find the y-intercept, this time, we're going to go ahead and substitute 0 in for x, and then we are going to go ahead and solve for y. So here, this cancels out, leaving us with 2y is equal to 4. You divide both sides by 2, so y is equal to 2. So the y-intercept coordinate point would be 0, 2. So now you have 1, 2 points, and you're ready to graph this line. So guys, I'm just going to go ahead and go to the side over here and graph it. Let me erase some of this. I'm erasing some of this, okay? So I can go ahead and graph this line. So I'm going to go to the XY plane, everybody. And I am going to sketch the graph of this line. So I go on the XY plane. I find where X is at -1 or -1, 0. Find the y-intercept at 0, 2. Plot my coordinate point and then sketch my graph. And guys, just like that, we're done. Any questions? All right, I am going to go ahead and do a second one, guys. Here's the second one. And this one, we saw it earlier. 4x minus 5y minus 20 equals to 0. Now, for this one right here, guys, we need to first take that 20, move it over. In other words, write it in standard form, and then find the x and the y-intercept. Move the 20 over first. So this becomes 4x minus 5y is equal to 20. Now we're going to find the x-intercept. When you're finding the x-intercept, remember you substitute 0n for y and solve for x. Now, when you plug in that 0n for y, guys, that's like saying this term doesn't exist. This term is not there. So you're left with 4x equals to 20. 4 times what gives you 20? 5. Okay? So guys, that's what's happening with this. So you get 5, 0 for your x-intercept. Now let's go ahead and do it with the y-intercept. Now when you're doing it for the y-intercept, guys, when you substitute that 0n for x, that's like saying that the 4x doesn't exist. So you're left with -4y is equal to 20. -5y is equal to 20. So -5 times what value gives you 20? Or 20 divided by -5 gives you -4. So guys, again, that is what is happening, okay? So 0, -4 will be the y-intercept. And once you have these 2 points, you're ready to go ahead and graph. So I'm just going to go to the xy plane. I'm going to find where x is equal to 5, plot my point, find where y is equal to -4, and then plot my point.